Hello all. Today we will try to solve some problems on subspaces, vector subspaces. So what is a subspace? Subspace are the subsets of the vector space. Okay. It behaves just like a vector space only. Okay. So I told you some three conditions related to vector spaces. What is that? The linear combination should be valid. So what are the linear combination operations? One is addition of two column vectors resulting in a column vector which will be in the same vector space. Okay. And second is the origin should be included. And the third is the any scalar multiplication should give a resultant column vector in the same vector space. Okay. So the question here is, which are the subspaces of R3? 3 means three-dimensional vector space. Okay, we have XYZ plane. Okay, which are the subspaces of R3 given as B1, B2, B3 as a column vector. Okay, so what to check here? So all the three conditions we can check here. If any of the one condition out of those three conditions what I mentioned, if it fails, then it is not a subspace. Okay. So coming to first question, that is B1 plus B2 minus B3. Okay. What is a null space and what is a column space? I'll just give a gist about it. When you write a matrix with X is equal to B, that is, see here, this one. This is called as a column space. Okay. Null space is defined when it is equal to 0. Okay. So this is called as null space. Suppose I have a vector 1, 2, 3, 4. Okay. And this is my matrix A. Okay. And the X will be, there are two variables, two components, right? One is X and other is Y. Okay. That will be equal to B1, B2, or it is equal to 0. If it is equal to some value, then it is a column space. So the A constitutes to column space. Whatever column, I mean, see here, if suppose this is a vector, A matrix, so in this 1, 2 is one column vector and 3, 4 is second column vector. So this constitutes a column space, column of A. Okay, column of A, and this, when this value is equal to 0, then the see, if you try to find out the X value, okay, if you try to find out the X value when AX is equal to 0, so the value is corresponding to X column, okay, that is XY column, that refers to the null space. Okay, are you getting it? So null space is nothing but as, if suppose, if what I can write here, if I write 0, 0, suppose X is equal to 0, okay, X is equal to 0 and Y is equal to 0. So resulting will be, the value is, if you do the matrix multiplication, the resulting value will be 0, right? So the XY value, the column having 0, 0 means the column, the origin itself is a null space here. Are you getting it? So that is called as null space. And the other part, when it is equivalent to some value, B1, B2, B3, then it is called as a column space. Okay, coming back to question here, the first question is B1 plus B2 minus B3 is equal to 0. Okay, we will try to put it in a form of AX is equal to B. Okay, can we put this first one? Can we put this in a AX into AX is equal to B form? So A matrix is here. See, you can see here 1, 1, minus 1. I can write it like this, and this as a X. Okay, and that is equal to null, 0. That is nothing but as a null space, correct? So this can be, this constitutes a null space. So null space also belongs to a vector space. So our solution is, so which are the subspaces of R3? The question is, which are the subspaces of R3? Given that there are 4 conditions, out of the 4 conditions we need to find out which all will satisfy the condition of subspace. Okay, so first condition satisfies because it refers to a null space. It is in the form of AX is equal to B. Okay, coming to second one, what is it? B1, B2 minus B3 is equal to 0. See, we are trying to multiply two column vectors here, b1 and b2 minus b3 is equal to 0. So according to this equation, what does it mean? b3 component, okay, b3 component is equal to b1 into b2, correct? So b3 component is b1 into b2. See, I will take one example. So this is, suppose these are the two vectors, v1 and v2, okay. These are the two vectors. Can you see here b3 2 is not equal to b2 into b3. So b1 into b2, sorry, b3 is not equal to b1 into b2, correct? So what I said, whenever a column vectors are multiplied or added or done any operation on those things, it should be there in the vector space provided. See here, but b3 is not equal to b1 into b2, where b1 and b2 is equal to 4 value is 4, but b3 is 2. So this doesn't satisfy this is not a subspace. b1 into b2 minus b3 is a 0. And very simple thing to understand is, when you try to multiply two columns, so it might result in a x square value, which is not linear, right? So in that way also you can get understood. Okay, coming to third question. What is it? We'll come here. b1, b2, b3 is equal to 1 0 0 plus c1 into 1 0 minus 1 c2 into 1 0 1. Okay, can we find out this column vector in terms of these two vectors? Yes, by multiplying by negative half and the positive half, and then it, suppose c1 is equal to minus 1 by 2, okay, and c2 is equal to 1 by 2. Try to multiply this. So minus 1 by 2 into 1 is 1 by 2. 1 by 2 0 minus 1 by 2. Okay, and this is minus 1 by 2, means minus 1 by 2 0 and minus 1 by 2. So this is 1 by 2. So adding that, do you get 1 0 0? See here, 1 by 2 into 1 0 1. So 1 by 2 0 minus 1 by 2 plus 1 by 2 0 1 by 2. So 1 by 2 1 by 2 1, 0 plus 0 is 0, and minus 1 by 2 plus 1 by 2, so it is 0. So one column vector we are trying to, so one column vector is the resultant of addition of two scalar multiplied column vectors. That is, see, I can write it like this: b1 b2 b3 is equal to, this value is nothing but as this part. Instead of writing 1 0 0, I will write this part, and plus the given c1 and c2. So can I write like this by taking column vectors, similar column vectors outside? So c1 plus 1 by 2 plus this column vector plus c2 plus 1 by 2 into this column vector. So this holds good the condition of vector space. So one column vector is resultant of scalar multiplication and also resultant of addition of the two column vectors. Okay, so this holds good. So this is a subspace. Okay, coming to fourth question. What is fourth question here? Okay, fourth question I have written, do it yourself, but still I will show you what is it. See, b1 b2 b3. Okay, b1 b2 b3 is equal to 0 1 0, c1 1 0 minus 1, and c2 1 0 1. Can you observe here, if you put any value of c1, the center part will be always 0, correct? Right? And c2, if you put any value in this scalar quantity c2, let it be 100, 1000, 200, 4, 5, 6, anything. So if you put any value, the center part is 0. Okay, and if you try to add these two, if you try to add these two, will you get this? No, because this is always 1. The center part is always 1, and this center part is always 0. If you try to add anything, even after the scalar multiplication, it will not give 1. So what it results to, whatever operation be on the right hand side, the center part will be always 1. So b1 b2 b3 cannot be 0, it cannot have 0 0 0, which means that it doesn't have a origin in that. Are you getting it? It doesn't have a origin in the space. So when the origin is not included, then it is not a subspace according to our condition. Origin also is a scalar multiplication of some column vector, right? When scalar multiplied with a 0, the scalar quantity is 0 there. Okay, origin is nothing but a scalar quantity is 0. So the multiplication condition is not, it will not work here, correct? So this is not a, fourth one is not a subspace because it doesn't constitute for origin. Okay, thank you.